No, I think we have that whole today.
Good, how are you?
Pretty good. Too short break.
Yeah, it's always short. All right, it's 5:30. Let's go and get started. All right, good evening, everyone. How's everyone doing today?
Good, pretty good.
Good to see everyone. All right, so this is EGME 540. It's called, the official name of the course is Computer Applications and Engineering Design. I think the unofficial name for the course is this is the ANSYS course. So my name is Professor Justin Tramp, so I will be your instructor for this class. So for today, I don't have any actual content plan. So my plan for today is just to kind of introduce the course to you, kind of what you can expect throughout the semester. So I have some slides to kind of outline that. And then I also wanted to go through the syllabus and the course website together with you. So should be pretty quick. For my last two classes, we finish in about 50 minutes. And so I expect this to be kind of more or less the same. But I will stick around after the class if you do have specific questions about enrollment or anything. Okay. Are there any kind of burning questions before we begin? Okay. All right. So let's go and get started. Okay. So first thing, just to introduce myself. So once again, my name is Professor Justin Tran. My office is in the engineering building. So that's not this building. It's the building right across the quad here. It's on the second floor and it's engineering 220. My email address is justran@fullerton.edu. So you can see it's kind of a combination of my name. Although I kind of always joke with people that, maybe I stole the email address of some running club here at Cal State Fullerton, but that's just how my name is. I do prefer that you email me. I know that Canvas has a messaging system where you can send messages through there. You can do that. I'm not going to get mad at you if you do that, but I do prefer kind of all my emails kind of be in one place. And so if you can, I prefer you email me directly to my email address. Okay. A little bit about my background. I am local to here, so I grew up in Cypress. If you don't know where that is, that's just kind of 9 miles west here on 91. So I'm very familiar with this area. A lot of my friends came to Cal State Fullerton. A ton of my friends still live in the area, so I'm a SoCal guy, kind of born and raised. All of my education has also been in California. So my bachelor's was at UCLA, my master's at UCSD, PhD was from Stanford, all in mechanical engineering. So kind of been right all up and down the California coast. My research interests, quite relevant for this class actually, is a lot of the work that I do utilizes engineering tools to study cardiovascular disease. So heart and blood disease, and the method that I use often is a finite element method, which is what we're going to cover in this class. Okay, and of course, being an instructor or being a professor in engineering for the past 6 years, of course, I'm interested in kind of the best ways to teach STEM as well. Okay, learning objectives. And so, I see a lot of familiar faces here, so probably you're familiar with this already. But if this is your first time taking me as an instructor, every class I always like to start with a list of learning objectives. So on a surface level, you can consider these learning objectives to be kind of an outline in terms of what we're going to go over that day. So it's always kind of a good thing to write them down. I always encourage people to write them down at the beginning of their notes. But I'm a little bit more intentional with these learning objectives. So if you kind of read each of the objectives that you have here, you'll see that each of them kind of begin with a verb. And the reason for that is, a lot of times, when you're taking a class, when you're getting a degree, the question is always, what kind of skills are you learning? What kinds of things are you going to be able to do after the class? Okay. And so I write these learning objectives in a way to kind of illustrate to you exactly what skills or exactly what actions or what kinds of things that you can do after taking this course, after taking this lecture. Okay. So for instance, after today, you should be able to describe the use and utility of finite element analysis in engineering work. Okay. So as soon as you walk outside that door, or as soon as you leave the Zoom room, you could take a quiz and I can ask you that, and you should be able to answer. Okay. And I do it in this way, also partially to kind of give you a way to assess your own learning as well. Okay. So after every lecture, one thing I always encourage my students to do is to look back at the learning objectives that were for that day. If you can accomplish all of those learning objectives after the lecture or after going through your notes, then that's great. That means that you picked up everything that I wanted you to get from that lecture, okay? If not, if you're not able to do those particular things, then that's probably a good idea for you to go back through your lecture notes, maybe watch the lecture recording one more time, to make sure that you can brush up on that before the next class, okay? The thing with education, the thing with learning a new skill is that, one of the most useful things that you can get is constant feedback from something, okay? Now, I'm going to be providing you feedback. I'm going to be providing you feedback on the projects, on the assignments that we do, but the more feedback that you can kind of give yourself, it's always going to be a good thing. And so the learning objectives are kind of your way to kind of, assess yourself, test yourself, give yourself feedback, and kind of, help you out that way. So you're not waiting until the next assignment or the next project where you need to kind of, give yourself, okay? So learning objectives, you'll see them at the beginning of every class, and I always encourage people to write them down. Okay, so what is this class about? So, this class has a very generic name. It's Computer Applications and Engineering Design. When I first taught this class 4 years ago, I kind of asked, what is this class about? What is the expectation? And, there's actually a lot of freedom. And so, the way I interpret this class is, how can we best use computer software to aid in engineering design? And one of the most important tools for this is finite element analysis, which, maybe some of you are aware, I am kind of the FEA guy of the department. I teach a lot of these classes. So I know some of you have probably already taken 541 with me. Some of you have probably taken 410 with me. Some of you probably have taken both with me already. So this is the class that, I think most people want to take, because we focus mostly on just learning ANSYS, okay? So what is finite element analysis? What is ANSYS? So in a nutshell, finite element analysis is a numerical technique for solving differential equations on arbitrary geometries. And so the idea is to leverage kind of the computing power that's kind of within modern computers to solve equations that are normally much too difficult for humans to solve on their own, okay? And through this, it allows us to kind of model physical behavior and predict the behavior of a physical system when you subject it to any kind of external effects like loads and constraints, okay? And this is a very powerful tool because, when you're working with physical systems, you're designing them, you're determining kind of the best way to go about things, having a tool that will let you predict things digitally without, you having to go out and build a physical kind of prototype is very valuable, because then you can try out different designs, you can try tweaks to your design, without having to, purchase a large, testing, okay? Okay. And by the way, today, all these notes are going to be available for you online too. So, definitely feel free to write things down if you want, but, the real kind of content is going to start on this. Okay. Okay, so finite element analysis kind of falls into analysis, which is kind of a branch of engineering that's used to learn more about a system, learn more about physical behavior. Okay, and so there's 3 types of analysis that are typically talked about when you're doing kind of engineering work. The first is what I call analytical analysis, and so this is kind of traditional kind of pen and paper calculation where you're given kind of a problem that is kind of governed by an equation, and you solve that equation using kind of pen and paper methods. Okay, so this is kind of traditionally probably what you do most of the time when you're taking a theoretical class, say in like structural mechanics or fluid mechanics. Okay, so analytical methods are very fast, they're very inexpensive, but they are very limited, and so you can only really use pen and paper calculations for very simple geometries, very simple situations. Okay. Once you start to add any kind of complexity, complex geometry, complex loading conditions, you can't really do those with pen and paper unless you're a mathematical savant, okay? The second type of analysis that you can do is what I call experimental analysis, okay? And so in experimental analysis, you basically go out and you run an experiment or you try it out in real life, okay? And so in this case, there's not really any math or any kind of equations that you're solving. You're literally just, trying it out in the real world and seeing what happens and collecting data, okay? So let's say you're designing an airplane. An experimental approach would be to actually build a prototype airplane and run it through a wind tunnel or put it in the air and kind of see what happens, okay? Now, the benefits of an experimental approach is that, that's what I call you get kind of the best data available. because there's no disputing the data. It actually happened in reality, okay? But of course, it can be very costly and very time consuming to run an experiment, okay? Now, the third type of analysis, which is what we're going to focus on for this class, is what's called computational analysis, okay? So computational analysis is very similar to analytical in the fact that we are solving differential equations, but instead of doing it by hand, we're doing it in a way that computers can solve, okay? And this allows us to handle very complex geometries, very complex situations, which is what most practical engineering falls into. Okay, so let's look at some examples. And so, what I'm showing you here is kind of very typical kind of beam analysis. And so we have kind of a straight beam, and we're applying a distributed load on top. Okay, so in a simple situation like this, you could probably solve the governing beam equations to solve, what is the deformation of this beam going to look like. Okay, so let's say that you apply this force. This beam is probably going to kind of deform something like this. Okay. So you can solve that equation, by hand. And for this case, because it's simple, probably is not that big a deal. Okay. But if you do a bit more of a complex situation, so let's say that you're designing a parking structure like this, this geometry is very complex. And so this would be very difficult to solve by hand. Okay, so this is something where you would need some kind of computer tool like finite element analysis to handle forward. All right, another example, heat transfer. So let's say that you want to solve for the temperature distribution in a solid wall, like so. Okay? So in this case, you could solve the heat equation. This is a fairly simple case, and you get temperature distribution. But for a more complicated case, say something like this, this would require computers to do. And then finally, we have fluid flow. So if you want to solve for the velocity distribution in a pipe, like so, in a simple case like this, you could probably solve this one by hand. You're just going to solve the Navier-Stokes equations. But for a more complicated case, you're going to need finite element analysis, some kind of computer software to help you. Because for something like this, this would be kind of almost impossible to solve. Okay, so those are some examples. I have the slide here to brainstorm more, but you guys are grad students, so I think we'll kind of skip this. But just kind of keep in mind kind of what application areas that you would want to apply finite elements to. And I think this class in particular is kind of exciting for you grad students. But, a lot of you are working full time or you're working on research, and so you probably already have some kind of applications where you can apply finite element analysis. And keep that in mind because that's something that you can use for the final project in this class. Okay. So next thing I want to go over, just because on Thursday we're actually going to jump straight into our first activity within ANSYS. So I want to go over kind of the general steps that are involved in performing a finite element simulation. Okay. So in this class, like I've mentioned, we're going to be focusing on one particular software. We're going to be focusing on ANSYS. Okay. But that's not the only finite element software that is out there. And so you may have heard of a software called Abacus, which is a product of Simula. And also, SolidWorks is kind of getting in the game as well, where they have their own finite element software as well. Okay. Now, when you go out and apply finite elements in the workplace, probably most companies will have a preferred tool. The reason for that is because all of these softwares are extremely expensive and most companies can only afford to buy one. So we're focusing on ANSYS because that's probably the most widely available one, the one that's kind of most widely used in companies. But just know that, the way I'm kind of teaching this class is that the methods and kind of the process that you're going to go through in ANSYS, you can also apply them in the different softwares as well, okay? The only thing that may change is that, maybe the buttons are in different places or, maybe the exact order of operation may be slightly different. But, no matter what software that you use, you're going to follow all of these steps of defining the geometry, specifying material properties, meshing, boundary conditions, solve, and analyze, okay? But we focus on ANSYS just because, we have Cal State Fullerton has a license agreement with ANSYS, and we can't afford to buy another software. Okay? Also, ANSYS has a free student version too. So if you want to download this on your home computer, you can do that as well. And it's one of the better ones. Yeah, question.
Out of curiosity, what is like the difference of SolidWorks?
Yeah, that's a good question. So every software kind of has a different niche in terms of kind of certain things that they're good at. SolidWorks simulation is honestly it's pretty new to the game. I think I honestly don't know that many people who have used it, so I don't know kind of what it's good for. It's convenient in the sense that most people do their design in SolidWorks, and so if you want to do analysis, it's kind of right there. I think that's kind of their motivation. But I think ANSYS has the most I would say validation in terms of most people have used it. People know it's reliable. But the difference between ANSYS and Abacus, ANSYS is typically used kind of more in the commercial world, so kind of more people that are working on design of products that are going to be put in practice kind of almost immediately. Abacus is more used in kind of the research sphere, so the people doing more academic research and kind of simulations for for research papers, things like that. So Abacus has a few more features that kind of let you do more complex stuff. ANSYS is a little bit more user friendly in my opinion, but it may not have everything that Abacus has.
Are you gonna need ANSYS downloaded like on our computers, or are we gonna have to use it on here?
We're gonna do all the activities here in the lab, but it is convenient to have it on your home computer so that if you don't finish in the class, you can work on that. Yeah. And I'll show you how to download it at the end of class. Any other questions on this before we move on? Okay. Okay, step one, defining the geometry. So first step, before you run any kind of finite element simulations, you need a CAD model for your geometry. Okay, so a CAD model is nothing more than just a digital representation of your geometry. So for the most part, you're going to be designing this geometry in mostly in other software. So most people use SolidWorks. So I think SolidWorks is kind of the industry standard for designing these. And the idea here is to get kind of a digital representation that has all the measurements, all of the kind of the geometrical features of the system that you want to analyze. Okay, so let's say that you want to analyze a bridge, run a simulation on a bridge. You need a CAD model, or you need a digital model of your bridge. Okay, if you want to run analysis on a particular beam, you need a CAD model for that beam. Okay. So softwares that can produce CAD models, SolidWorks is the most common one. CATIA is another common one I see kind of a lot of people learning nowadays. CATIA is kind of more common in the aerospace industry. AutoCAD is kind of probably the first one that most people learn. And Creo is another one as well. So there's a lot of different CAD software. Okay. So basically your geometry, you can think of it as almost kind of like the subject of your simulation. Okay? Your geometry is going to be, how it's the main thing that you want to answer questions about for your design and analysis. Okay. So some CAD some finite element softwares do have their own CAD tools. You're going to see ANSYS actually has a CAD software that's kind of built into it, but usually it's not as full featured as like SolidWorks. So for the most part, I generally recommend people to use SolidWorks to produce their parts and then run their analysis within ANSYS itself. Okay. Now for this class, we're not going to be producing our own CAD models, with the exception of the first activity. The first activity, the geometry is so simple, we're just going to make it. But for the most part in this class, I'm going to be providing you the CAD model. So you don't need to, open up SolidWorks for this class. Having knowledge of SolidWorks does help, of course. But we're not actually going to be doing any modeling. So I'll provide those to you, and we're going to be focusing just on the finite element analysis. All right, step two. So step two is to specify the material properties. So this is probably one thing that you don't usually do in SolidWorks, because you're not performing any analysis. But it's important to specify, what kind of material your geometry is made of. So whether it's made out of, a hard metal like steel, or soft metal like copper, or maybe a balanced one like aluminum. What material that you choose for your model is going to affect the simulation results. Okay. And that makes sense in reality too. So a steel bar is going to be much more difficult to deform rather than a plastic bar. And you want to make sure that you input this information into the software so that they can take advantage of that as well. Okay. So in this class, we'll actually be diving into this quite a bit, because not only do you have to choose the material properties, but different materials will have different behaviors as well. Okay. So I think probably what most people are used to are what's called linear isotropic materials. which are like most of your metals. But materials like plastics, like composites, like wood, those have different material models as well, where maybe you have to apply stiffness in different stiffness in different directions, because that's going to affect your results. Okay. So for instance, for a block of wood, whichever direction the fibers in the wood are running, you want to make sure you're aware of that, because that's going to affect, the strength of that wood in different directions. Okay. So we'll be talking about anisotropic materials, orthotropic materials, nonlinear materials, hyperelastic materials in this class, and we're going to talk about how that affects your results. Okay. So we're not going to be, for the first half of the class, we're going to be dealing with mostly simple material models. But then once we get kind of to the second half of the class, that's where we're going to dive kind of a bit more deeper into this. Okay. This is probably one thing that kind of separates kind of maybe a different finite element class in 410 compared to this one. So we're going to be diving more into these kind of advanced features. All right, meshing. Probably the most iconic feature of finite elements is to put a mesh on your model. Okay, so meshing, kind of in a nutshell, is to break up your geometry into much simpler shapes. Okay, so the idea is to basically turn your geometry into a Lego set. Basically, that's kind of the analogy I tell people. The reason for this is that eventually we're going to be solving, or the computer is going to be solving, some very complicated differential equations on this geometry. And when you do it on something like this with a bunch of arbitrary curves and edges, it can be difficult. And so by putting a mesh, you're basically breaking it up. You're basically breaking up your geometry into a bunch of known shapes with a known amount of faces and a known amount of edges. Okay. And so, for example, for this geometry here, you can see that we've broken the surface up into all triangles. Okay. And then on the interior, those triangles actually turn into tetrahedrons. Okay. So this is actually really important, and you need to do this in order to solve the equation. Okay. And what you choose for the mesh, or how you measure geometry, is probably the single most important factor that's going to determine the quality of your simulation. Okay. So we're going to be spending a lot of time on meshing in terms of how we actually do this, what are the best practices, what are the factors of the mesh that affect your results. So meshing is something that's going to be really, really important. Okay. But kind of a very simple kind of way to think about your mesh is that the smaller your elements are, the more accurate your simulation is going to be. Okay. Think of it like the resolution on a photo. So the more pixels there are in your photo, the more high quality the image is going to be. Okay, next thing, questions.
About the meshing.
Yeah.
What could go wrong?
Yeah, so meshing, so probably the most difficult thing that people have with meshing is that if your geometry is very complex, it may be very difficult for the software to actually break it down into these simple shapes. So there may be kind of a weird part of the geometry. So we'll talk about techniques to kind of handle these kind of weird, complex geometries. But the other thing with the meshing is that even though, generally more elements and more pixels means a higher quality simulation, but that also means your simulation is going to be more expensive as well. So there's a big kind of cost benefit analysis of how many elements do you need versus how much can you kind of get away. Yeah, because it's very easy. You can say that I'm going to produce a mesh with 9 billion elements. It's going to be the most accurate simulation in the world. But it's also going to take you 90 years to run the simulation, which is most people don't have that time to wait. Okay, next we have the boundary conditions. So boundary conditions are kind of what I described as kind of external effects on your geometry. Okay. The important thing to remember with finite elements is that you're simulating a real life kind of object with real life loads and effects, and so you need to incorporate those mathematically onto your model. And the way you do that is through boundary conditions. Okay. So we're going to talk about two main types of boundary conditions. The first being loads, and the other being constraints. Okay. And it's important that you kind of get these accurate in order to get an accurate, response from your model. Okay. So some examples of boundary conditions would be maybe like a pressure force that's acting on your model. Maybe your model is fixed at a certain location. You want to make sure you get that information in there. Maybe there's a force being applied. Maybe there's a torque being applied. So all of those kind of external effects are applied on the boundary conditions. Okay. All right. And then kind of the penultimate step here is to solve the equation. So actually, usually when you're taking another engineering class and someone says solve, this is usually where you spend most of your work. in finite elements is actually the opposite. When you click solve, then you just kind of let the computer do its thing. So you say, all right, computer, go. And then you just kind of cheer it on while it's solving your system. Okay. Because this is the complicated part. So this is, now that you kind of defined your problem, the computer is now going to solve the equations on your model. Okay. And so during this step, thousands, millions, sometimes even billions of calculations are being done in order to get your simulation results. Okay. So, we're not going to spend too much time talking about this step just because the computer does handle it. But there are some kind of, considerations for you to do or for you to think about from a practical perspective in terms of how you can set up your finite element simulation to make the solve step more, good. Okay. But we'll probably save this until the very, very end. And it's important to note too that there's a very wide range of costs for finite element simulations as well. So most simulations that we're going to do in this class are what I consider to be fairly small. And so what that means that you can do them on your desktop computer or your laptop computer. But it's also very easy to get simulations that have millions of elements that require a supercomputer cluster to do as well. Okay? All right, and then the last step is to just analyze your results. So after you solve the simulation, you'll be able to get color contour plots of things like the deformation, things like the stress inside your structure or the strain. Okay, and you can use those results to do your design or analysis. Okay, so these kinds of plots will be very kind of you'll see these almost every week in this class, which is basically like a heat map that shows you the results. Okay. So the way to kind of read these figures is, the colors represent different magnitudes of the whatever quantity of interest that you're looking at. So let's say, for instance, I know this says strain here, but let's pretend that this says deformation, okay? And so, what this is telling you is that the red areas are the areas which have the higher amounts of deformation, and the blue areas have almost zero deformation, okay? So utilizing these color contour plots and analyzing them is an important step that you're going to do for for a lot of this class. Okay. Okay. Any questions on this so far? Okay, good. Yeah, so that's the finite element process in a nutshell. And so, we're going to put this in practice on Thursday. But I did want to kind of preview it today so that, so because Thursday, honestly, is going to be a little bit hectic. It's kind of everyone's first time with ANSYS, or, for some of you, maybe the second time. But, I wanted to go over this now just so that, you kind of have an idea of the process before we get started on. Okay. Okay. And so the last thing that we'll talk about here is that, like I mentioned before, that finite elements is at this point, kind of an integral part of engineering design. Okay. Because having a digital platform here that allows you to predict behavior lets you kind of make changes to your design and tinker with it in ways that a physical test would basically not allow you to do, at least in a practical sense. Okay. So if you look at the design process, the modern design process nowadays, compared to what it was, 40, 50 years ago, simulations have almost eliminated the need for physical testing. Okay. Whereas before, if you wanted to make a change to a design or you wanted to kind of propose something different, it would take you time to build a prototype and get the data and show that improvement. Nowadays, you can just run it on a computer, run it through a finite element simulation and kind of know right away. Okay. But one thing I want to stress here is that, finite elements, even though it's a very powerful tool, I'm probably the biggest cheerleader for finite elements there is in this university. But I will be the first to tell you that a simulation is never going to replace physical testing. Physical testing will always have its place in engineering because you can tinker with something all you want in a computer, but whether your simulation results actually recreate reality, is something that you always need to verify before you actually make a product or before you publish a design. Okay, so even though simulation technology has come a long way, the equations that we're solving are verified to be accurate in most situations. There's still a possibility that, maybe you set up the simulation incorrectly, or maybe, the computer wasn't able to solve this, or maybe there was an error. And so you always want to verify your simulation with physical testing, okay? So I want to emphasize that, just because, I don't want you guys going out of this class and telling other professors that experiments suck, experiments are useless. Like, no, I didn't say that. Experiments are still really important, but, simulations have their own kind of niche. They have their own role in design. Okay. Okay. And then this kind of just says the same thing. And in fact, among people that do FEA, there's a very common phrase that's kind of thrown around, which is called garbage in, garbage out. And so what that basically means is that if you put garbage into your simulation, you're going to get garbage out. And so if you don't set up your simulation properly, your mesh is not well refined, your boundary conditions are incorrect, maybe you're using a wrong material property, you're going to get an incorrect result. Okay. So FEA is not a miracle tool. It has its limitations, and there is kind of best practices for you to learn as well. Okay. And that's kind of the purpose of this class, is kind of learn those best practices so you can utilize them in your professional work. Okay. Okay, and then here's just kind of a very brief overview of everything that we're going to learn in this class. And so I always show one of these just because, that's just kind of how I naturally kind of visualize things in my head. I'm a very visual kind of person, but we're going to basically be following this flow chart throughout the process. Okay. Okay, we'll kind of skip that because we're not going to do too much more. Any questions before we jump into the syllabus? Okay. All right, so let's talk about the syllabus. So I think I sent the syllabus to everyone through email, but I did want to go over kind of the most important things today. Okay. All right, so first let's talk about office hours. So once again, my office is in the engineering building, and so that's not this building that we're sitting in. It's the building across the quad. My office is on the second floor of Engineering 220, and I have office hours 3 times a week. Okay. So I have office hours on Monday morning from 10 a.m. to 11 a.m. This office hours is the only one that's virtual only, just because I'm not on campus on Monday mornings. And so if you want to attend Monday office hours, you can only do that on Zoom. Okay. And then my other office hour times are Tuesday, Thursday from 2:30 to 3:30. Okay. Now I know this is a grad course, so I know most of you probably have work during those times. And so if you're not able to make it to those office hours, please don't feel like you have to take the day off to talk to me. I'm also available via appointment as well. And so if you need to talk to me about your project or a homework assignment, just send me an email and we can probably set up a time, maybe after the lecture or maybe early in the mornings, kind of what kind of works best for you. Okay. So office hours, mostly are there for you to ask questions about the course. And so if you have questions about kind of a recent lecture, or if you have questions on a homework assignment or a project, office hours are the best times to ask those questions, because literally the only thing I'm doing in office hours is just sitting in my office and just waiting for people to ask questions. And sometimes no one comes, and sometimes I just twiddle my thumbs for 300 times before someone comes. Right? But for all the office hours, Monday, Tuesday, Thursday, I am available on Zoom as well. Okay. I think, what happens sometimes is, maybe for my grad students, maybe you can take a break during work and talk to me. That works too. But again, don't feel like you need to take a break during work or take time off work. Just email me. We'll find a time to meet up and chat. Okay. Okay, learning objectives. And so, we already talked about this at the beginning of class, but I also have learning objectives for the entire course as a whole. And so by the time you finish this course, you should be able to do these 4 things. And so, I kind of designed this course and organized this course around those 4 learning objectives. Okay. So that's something good to kind of keep in mind as we go through the semester, and kind of maybe check in at the end to make sure that, that you get all the stuff. Okay. Okay. So let's talk deliverables. So I know I have exams at the top there, but there are no exams in this class. Okay. So, like I mentioned before, this is kind of the ANSYS skills class. And so basically everything that we do in this class kind of has to do with ANSYS. Okay. So there are 8 assignments, 1 midterm project and 1 final project. Okay. So the 8 assignments, those are basically all going to be ANSYS lab activities. And so what's going to happen with those assignments is that, we're going to do some activity in the class where I teach you kind of a new feature or a new kind of a new functionality within ANSYS itself. So for the first half, so for the first 4 activities, those are going to be kind of ANSYS basics. And so we're going to learn how to use the software, how to conduct a simulation, and kind of different parts of that. The second half of the class is all going to be advanced features within ANSYS. Okay. So all of those they're graded on completion. So because the activities are, you're part of the activities, we're learning the answers, and also because you guys are grad students, I don't grade the homeworks for correctness. The activities are kind of there just for you guys to experiment with answers, try it out, and learn. So as long as you do the activities and I see that you completed every single part, I give you full credit for it. Okay. The things that I do grade you on for this class is one midterm project and one final project. Okay. We'll talk about those in a bit. Okay. Now, the lowest homework activity is dropped, so that does give you some flexibility if you're not able to make a deadline just because things are busy with work or things are busy with your other courses. I wanted to give you guys that flexibility. Okay, but please do them all. They all, they're all kind of designed. If you do all of them, they kind of paint a complete picture of answers. And so if you skip one, then you kind of are missing one. So even if you're not able to get one done in time, I do still encourage you to do them. Just so that you can pick up all of these skills. So those activities are kind of your chance to kind of experiment with answers. Okay. And just like most things in engineering, listening to me talk about it twice a week is usually not sufficient to actually learn a new skill. So you actually need to try it yourself, and the activities are kind of your chance to do that. Okay. So the midterm project is going to be basically a full-fledged what I call finite element analysis. And so for the midterm project, I'm going to give you a geometry, and I'm going to tell you, do a full analysis on this geometry. Give me all of the results, give me all of the analysis, justify all your methods, and that's the project. Okay. Final project is going to be mostly the same thing, except you're going to need to incorporate some of the more advanced features within ANSYS. Okay. So the due dates for the projects right now. So for the midterm project, I have it planned a due date of Sunday, March 23rd by 11:59 p.m. Okay. And the final report for your final project is going to be due the Monday after finals. So finals week is, I believe, May 10th until Friday after that. And so May 19th is the Monday after that. Okay. So I actually just learned that our commencement is actually that day. And so if this is your last semester, please finish your project before commencement. So don't be coming up to me at commencement and ask me questions about the project. Okay. But I always have the project due the Monday after just to give you guys a little bit more time. Especially because I know you guys are, a lot of you are working, a lot of you guys have families, so I want to give you extra time. Any questions on the deliverables for the class? All right, grades. So fairly standard grading breakdown. So homeworks are worth 10%. Again, the homeworks are all, based on completion. So as long as you do all the activity, that's 10% of your grade. Midterm project is 40%. Final project is worth 50%. Okay. So it's not a lot of entries. So a lot of your grade is going to be due based on those projects. And so you want to make sure that those projects are kind of high quality and make sure that you're kind of talking to me, making sure that you're on track with that. Yeah. Oh, of course. Yeah. So even though I'll be grading your homeworks for completion, I will be looking at them and giving you comments and feedback on it. Yeah. And the project as well. And so, the project is not just going to be something I drop on you guys. There's going to be time, in the class that we're going to work on it and chance for you guys to ask questions on that. All right, and then based on how you do on the homeworks and the projects, the final grades will be assigned. Your final letter grade will be assigned based on that breakdown there. So I think that's fairly standard. So 90% and above is A, 80% and above is B, 70% and so on and so forth. Okay. I do apply scaling sometimes, and so what that means is that if the overall class average is below a certain threshold at the end of the semester. So let's say that the overall class average in the class was about 75%. So for this class, this is a grad course. So my threshold is a little bit higher. So I'd like to have my threshold be about maybe 80, 81, 82%. Kind of depends on how the semester goes. If the overall class average is below that, what I'll do is I'll add points to everyone's grade until that threshold is dismissed. Okay. So what that means is that I don't curve the projects. So I don't apply any adjustments until the very end. Okay. Usually for this class, I don't apply any adjustment just because, usually you guys do a pretty good job with the projects. But I still will do that at the end if I do. Any questions on the grading system? Okay. Textbook. So textbook is not required. In fact, I post all my lecture notes, and so there's going to be no point in the semester where I assign you a reading from the textbook. But it can be a good resource, okay? And so the textbook I use for this class is the 2020 version of this textbook. But it's a pretty good textbook, and so I think they're probably on 2025 at this point. So you don't have to get specifically the 2020 version. That's just the one that I got for free, and I just don't want to buy another one. And so but probably a more recent version of the textbook will have be a bit more updated. Okay. I like this textbook a lot just because it's very visual, and so it shows you a lot of screenshots. It shows you a lot of figures that kind of help you out with that. Okay. It's also fairly reasonable too. So I think when I bought the textbook, it was maybe about 50, 60 bucks, and so probably it should be around that price too. Okay. But again, I post the full activities online. I post all my lecture notes, and so I think nowadays a lot of students just use my lecture notes. They don't get the textbook. But this is a good reference for you to have. This textbook in particular, if you're going to be one of those people that have an office at an engineering company, this is a good textbook to have in your bookshelf to show that yes, I am a real engineer. I have engineering bachelor's. This is a good one to have. And as always, I always tell people, please don't pay full price for a textbook. If you happen to find a PDF version of the textbook while surfing the internet, I would say, I would not discourage you from getting that, although officially I can't encourage you for doing that. I've been telling everyone today that I graduated from college back in 2013, and still to this day I have a burning hatred for the textbook companies that made me spend hundreds of dollars on textbooks on things that I only use for attendance. And so I'm a very resentful and very kind of person. So that hatred kind of still persists to this day. And so the fact that I chose this as my career, and I tell people, don't buy a full price textbook, is my way of kind of getting revenge. And I will hold on to this until the day I retire. Okay, course website, Canvas. And so we're going to take a tour of the course website after this, but just know that all the content that I produce for this class will be posted on Canvas. And I'm pretty active on there. I'm on there every day. I don't post something every day, but it's at least once a week. You should be able to see new lecture notes or new PDFs, new handouts, things like that. Okay. So make sure that you're staying up to date on Canvas. Canvas is also the primary way that you're going to turn in assignments. I do offer the option if you wanted to print out your activity reports and hand them to me. That's fine as well. But no one's done that for the past 4 years. So Canvas is probably going to be where you're going to be uploading things. Okay. I also use Canvas to send announcements to you, but the Canvas system also sends you an email, I believe, whenever I put an announcement. So, but just know that if you get an email from Canvas, it's from me or one of your other tutors. Okay. All right, policies. So these are just kind of the rest of the miscellaneous policies for the course. So I do accept late homeworks. I say that because someone's going to ask me next week again. So even though there's a due date for the assignments, I do accept late homework up to a week after it's due. Okay. But if you do turn in a homework late, I do dock 10% of the points from your score. Okay. And again, this is just to kind of give you some more flexibility in how you turn in your assignments. Okay. So primarily, like I mentioned, most people are going to turn in their assignments on Canvas. But also Canvas has its issues sometimes too. Sometimes it won't let you upload. So if you're having issues with Canvas, you can always just email it to me as well. Okay, and that's perfectly fine. Regrades. And so for this class, this is mostly going to be for the projects. But I do offer regrades. Okay, and so if you get your project back and you read my feedback and you think I graded something incorrectly, or maybe graded unfairly, or maybe just simply I just added up the points incorrectly, which happens at least once a semester. Please let me know. I'm always happy to look at things again with you, or maybe discuss your grade with you. Almost at any time. Okay. The only limitation that I have with regrades is that I do place a 1 week deadline on it, okay? And so when I grade something, when I return it to you, you have 1 week to look at the comments and look at the feedback and request a regrade, okay? Part of this is to kind of prevent the thing that happens every semester where it's week 16 and, people want me to look back on something that they did in week 2 and regrade it just because they need a couple extra points for an A. So, this kind of prevents that thing from happening. But also, when I grade your stuff, your assignments, your projects, I'm giving you guys feedback and giving you guys comments in terms of, where I think you can improve, your understanding. And so, that feedback and those comments are really only valuable, in that moment. And so if you wait a month, if you wait 2 months to read that feedback, we've kind of already moved on to something, way beyond that, okay? So this 1 week deadline of requesting a regrade is to encourage you guys, to look at those comments, read them, just so that they're kind of more time, okay? And then lastly, emails. And so, like I mentioned earlier, I do prefer that you send me emails if you need to contact me or ask me a question. You can use the Canvas messaging system, but I do prefer that you just email me directly. Okay. And if you are going to email me, I do ask that you include EGME 540 in the subject line of the email, just so that I know that you're asking about this class, because I'm teaching 2 other classes. I have advising. Have all my research stuff, and so it's just kind of helpful for me to kind of organize my. Okay, and usually I'm pretty good with emails. I try to respond to everyone within about 48 hours. A lot of times it's less than that, because I'm at my computer at my desk a lot of the time. But please allow me up to 48 hours to answer you, except on meetings. Okay. All right. Any questions on this so far? Okay. All right, academic dishonesty. So, I hate having to talk about this, especially just because you guys are grad students. You guys are all adults. But academic dishonesty, we have very strict policies on that from the university, from the college. So, if you copy something, or use AI, there's kind of very strict punishments. Okay. And one thing that I do that maybe not everyone. Maybe not every instructor does it, that I take a pretty hardline stance on the use of AI, okay? So that includes using ChatGPT on your homework assignments and your project, okay? So basically, I don't allow any of this at all. And if I detect that, if I see it, then, there's, I consider that basically academic science, okay? And I do this, for a very kind of specific reason. And, I think, in terms of AI, I think this world is, we're kind of at a turning point where, I think a lot of employers are kind of asking the question of, what aspects of our business or what staff can we replace with AI? And, I see a future, not too far from now where, that's going to be reality. Even my own job, I guarantee you that, the provost, especially the provost, and the chancellor and the presidents, they're thinking, how soon can we replace Justin with AI Justin, and then take his salary and add it to our own? I guarantee you that that's a conversation happening. Even though they're not, even though they say that's not happening, those administrators, they lie all the time, and so I guarantee you that's happening. So for the past couple of years, I've been working with the mindset of I want to show that I can provide you guys, students, more value than an AI ever could. Okay. And I think, we're not too far from the future where you guys are going to go out and for your companies, you have to kind of prove this. And when you're in kind of an educational environment like this, the whole point of taking this class and getting a degree is to learn these skills, right? It would be one thing if I were assigning you these projects and, and I just needed it done, or, maybe you're doing this project and I'm going to submit your report to a boss, or I'm going to sell your simulation results and I just need it done. And so in that case, whatever, use AI, I just need it done. But, taking a course like this is different because you're taking this course to learn those skills. If an AI is doing the writing for you, if it's doing your simulations for you, then you're not learning those skills. And, in that case, you're kind of adding fuel to the fire of, an AI did your assignment, so an AI can do your job. Okay. And, that's a future that I'm, very scared. And so for that reason, I don't use AI for any parts of my work. I write every single one of my emails. I do all my grading myself. I've heard some high school teachers using AI to grade stuff, which is nuts. But, you know, and I want the same thing for you guys as well. Okay. And in exchange, you know, because I know, you know, AI makes things very convenient. You know, I know it's a pain to do all of these assignments. It's a pain to write the reports, do the simulation. I get it. It's time consuming. But my promise to you is that, you know, my role here, my job is to make sure that you guys, or to do everything I can to make sure you guys succeed, to make sure you guys reach your goals, you know, to make sure you guys graduate, do well in this class. And so I promise you that if you give me a chance, you come to me and you tell me you're struggling, you don't know what's going on with the class, you tell me you're struggling with the project, you know, I promise you, I'm not going to judge you, I'm not going to criticize you, I'm not going to look down on you. You know, I don't even tell my wife the conversations I have with students, because that's between me and you, right? And I will do everything I can to help you guys, because that's my job. Okay. So come to me, you know, don't turn to ChatGPT, and I promise I will. Okay. So last thing I want to cover before we get to the course website is the first homework assignment. So homework 0. Okay. So the first homework assignment is to just send me an email just to introduce yourself. Okay. So very simple, and just for sending me an email, you're going to get full credit. Okay. I have some questions here that you can answer. You don't have to answer these 4 questions, but I have them there in case you're you know, you're struggling to find out what to talk about. Okay. But even if you just send me an email, say, hey, my name is this, give me credit, then I will give you credit, full credit. Okay. So this way, everyone starts with an A, which is always a very good place to start. And I get to learn a little bit more about you too. Okay. Because, you know, a semester is very long. You know, we're going to be together until the middle of May. And so that is 16 long weeks. And so, you know, I want to get to know you. Okay? So, you know, question 1, again, you don't have to answer these, but, you know, what kind of career would you like to have? Maybe a career that you are working in right now. Okay. What would you most like to learn from this course? Number 3, you know, what kinds of worries or concerns you have for the course? That's a very important one. If there's anything I can do to kind of alleviate those concerns, you know, I would like to know so I can do it. Okay. And number 4, just for fun, you know, what are your interests and hobbies? So, you know, I'll start. So, you know, I have a strong interest in cooking, so that's kind of one of my favorite things to do in my spare time. So, you know, I won't claim that I'm very good at it, but you know, it's something that I've enjoyed for a long time. And you know, I think the joy of kind of cooking something and providing it to someone that you care about and having them say it's delicious is great. So, you know, I cook for my wife a lot at home. And even though, you know, 4 times out of 5, she'll say like, this is too salty, or this is too sweet, or this is too dry, it's overcooked. And I'm just like, woman, I spent 3 hours making this for you. You know, that 20% of the time where she said, this is delicious, I love you, that makes it all worth it. So my other interest is I watch anime, I play video games, and so, you know, I'm very much kind of a weeb. And I have 2 cats, and so I have 2 cats that I love very much. Yeah, a lot of times when you see me at the beginning of class, I'm just looking at my phone. I'm not chatting with my friends. I'm literally looking at pictures of my cats. So yeah, so send me, you know, information about yourself, and you know, we can start this semester. Okay. Any questions on this? Okay. All right. So the due date for this is this Sunday. So if you send me an email by this Sunday, you'll get full credit for it. And by the way, I read every single one of these emails, and I respond to every one of these emails as well. Okay. That's pretty much takes up all my time in my first week, but this is my favorite week of the semester. Okay. So last thing I want to do before we head out is I do want to give you a quick tour of the course website. Okay. Just to kind of show you where everything is. Okay, so when you go to the Canvas site, this is what you're going to see. So you're going to see EGME 540, Computer Applications Engineering Design. That's me. That's the class times, and this is the class location. So all of you know this because all of you are here. If you don't know this, then you're not here. Okay? Course description, this is lifted straight from the syllabus. Learning objectives as well. Okay. And if you want the full PDF of the syllabus, it's available for you to download here. But you know, we just went over this together in class, and so you know, there's not much more that you can do. Okay. All right. So Zoom links. So you know, I do stream all of the lectures, and actually for this class, since we don't have any exams, you're actually free to attend the entire class virtually. Okay. So you know, whether you're here or not, you know, it's of course I'd like to see you. I don't want to make it seem like I don't want to see you. But if it's more convenient for you to attend the lectures over Zoom, then that option is available for you. Okay. I also have all the Zoom links here for the office hours, and so the times here are there to remind you as well. Okay. And just remember that Monday is virtual only. Okay, so if you want to see me on Mondays, this is the only way that you can do that. Okay. But the most important aspect of the homepage here is at the bottom, where you can see kind of a week by week breakdown of all the topics we're going to cover in this class. Okay. So right now we're in week 1. So week 1 is the only one which is clickable. But as we go through the semester, all the different weeks here will be clickable as well. Okay. So let's click on week 1 right here to kind of show you what you can expect in what I call these the weekly groups. Okay. So for each week, I make a page on Canvas here, which kind of shows you tells you kind of a little bit about what we're going to learn that week, all the learning objectives for that week as well. Okay. All of the lecture recordings. And so, because I stream everything on Zoom, it is automatically recorded. And so I do post those on YouTube. And so if you want to review the recordings for the lecture, the easiest way to find them is to go to the weekly pages here. Okay. And it's organized by week. We have 2 lectures per week. So we have week 1, lecture 1. That's the one we're doing today. And then week 1, lecture 2. That's what we're going to do on Thursday. Okay. All the assignments that are due that week or all the activities that we're going to do that week are going to be here as well. And any of the lecture notes or any files that we need for the activities will be here as well. Okay. So usually I publish these weekly pages on Friday, the Friday prior to the week. And so the weekly page for week 2 will be up probably sometime Friday afternoon. That's usually when I have time to do. Okay. So I usually recommend, either on Fridays, before you head off for the weekend, or maybe on Mondays, take a look at the weekly page for that week, download all the files that you need, and kind of read a little bit just to kind of give you a heads up of what we're learning that week. Okay. Okay. So that's the home page. So you're definitely going to be visiting this page a lot. Right, I should show this one as well. So this tab is the announcements. And so probably most likely you're not going to come here because all of these announcements are going to be emailed to you directly. But if you want to reference one of the previous announcements, you can come here as well. Okay. I don't send announcements very often. Usually they're going to be just reminders of due dates for the projects. Or maybe if there's a typo or something, or there's a correction that needs to be done, that's usually what I use announcements for. But I don't send them very often. Okay. Okay, assignments. And so the next tab here will show you all the assignments for the class and when they're due as well. And when you complete your activity, this is where you're going to upload it as well. Okay. Grades. And so, you can check your current grade in the course based on your scores here. Okay. Pretty straightforward. People. So this has a list of everyone that's in the class. Okay. Pages. You don't need to see that. That's where I publish all the content. And then the files tab, this is probably the place you're going to visit the second most. All of the lecture notes, all of the ANSYS files that we're going to need for the class, all of the specifications for the project will be published here. So you can find them here as well. Okay. And they're organized into different folders. So I have a folder here for ANSYS files. Okay. I think all the ANSYS files that we're going to need for the semester are here as well. Okay. Assignments, I'll post assignments here as I make them. Final project, midterm project, these are empty. I'll post things in there when we need to. All the lecture notes for this semester are posted as well. So if you wanted to read ahead, you can do that. Okay. I'm also going to post solutions here as well for the ANSYS activities. Okay. All right. Any questions on the Canvas sites? Okay. All right, so that's all I have time for today. So I know it was a little bit longer than I thought, but we're still ending a bit early. And so when we come back on Thursday, we're going to do our first ANSYS activity. And so if you're going to be following along on Zoom, then make sure you download ANSYS to your home computers. Oh, let me show you how to do that really quick. So if you're going to download ANSYS to your home computer, you're going to search for ANSYS Student. Okay. And you're going to see here that's going to lead you to a link called ANSYS Student Versions. And so you're going to download ANSYS Student, and it's completely free, okay? But of course, if you're going to do the activity here in class, you can just use the ANSYS that should already be installed on the computer. Okay? But thank you guys for coming today. It was great meeting you all. I'll stick around for a bit longer if you have questions about enrollment or anything, but I will hope you guys have a good rest of your evening. I will see you on Thursday. Hi. Hi. How's it going? Thank you. Yeah.
40-50%, are those things that we're gonna be doing like throughout the year, or is it gonna be like a one day, give us the 1 2 week?
So for both projects, we have to work on. And so kind of the structure of our project is that we're gonna do activities, good activities.
No,
And then at that point, we'll have everything we need for the project, all sign the project.
Okay.
And then for the final project, the final project, is the same thing. We'll do the activities, all sign the final project, give them a full amount.
Okay, perfect, then within that, let's see. I thought it was perfect, yeah. And I don't.
Yeah.
Sometimes, you know, like you gotta, if you think like, you know, like you look at it for the research, instead of looking for.
Of course. Oh, yeah, yeah.
So I was just making sure, you know, like I can.
Of course. Oh, yeah, Oh, yeah, yeah. It's not a short thing. There's
Okay.
very important.
Oh. And honestly, I feel like it's something really very helpful. I work with, so, but I'm on education, I'm typically working on Monday or these companies, like, oh, this is like the kind of thing.
Yeah, yeah, if you're doing any kind of design or analysis, then FBA's,
Yeah, I'm looking forward to this.
Yeah,
Yeah, so,
Oh,
we did our undergraduate here together, and
Oh,
now
cool.
we're doing our masters together.
Oh, awesome. Welcome back.
So we've been here for like 7 years now.
Oh, my gosh.
That's been a bit.
So, you know, Dr. Dave,
Yeah, yeah, of course.
he knows us like,
I've been with him, like,
we've been with him for probably.
He's raised when we were.
Yeah. We did our, we did classes on research. He raised his hand and now.
Research?
Research.
Oh, my goodness. So he's like,
Yeah.
That's great. Oh, that's glad you got me back.
Yeah. I think it's, this semester that I'm gonna have one more.
We're taking 4 classes. You know, this topic, I really think to be like a very tough topic, it needs some work, but I mean, honestly, I don't have issue with working as long as I know what I'm doing, you know what I mean? You know,
It's there, to be honest, 40%, 50%.
that was the kind of, yeah.
Yeah, when I saw that, I was like, that's why I asked it, because people are.
Of course, of course.
Just in case, you know. if
Well,
something that we're doing wrong, we can-
of course, the project is, you do activity and spot and. So we can go back. So we can go back.
Yeah, what time? Plenty of time. Yes.
40%.
Kind of scary.
Yeah. Oh, I'm sure. Give you a Professor, pleasure.
Yeah.
Yes.
Yeah. So Thursday. Yeah, see you Thursday. Hi. Good.
I am.
Okay. Well, so I was telling those guys that, you know, I signed up for it, you have like a month to work on it. So for the usual time is not an issue. Before you go, when you want all your thoughts and stuff.
Usually they'll set up, they'll get this back or like.
Usually not, but I am quite, I'm flexible with that too. And so if people need more time for it, or, you know, if you need to flexible, I can.
Okay, that's fine. I'll send it.
Okay, cool.
Yeah, thanks, man. We're gonna.
Hey, Dominic. Let's talk in my office about your project. I like your team. You had a good game this weekend.
No. I was out on Roscoe's in downtown Fullerton.
Oh, yeah?